Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss about ICMP protocol, which is called as Internet Control Message Protocol. First, let me discuss where this protocol will be there, in which layer it will be there. Then I will discuss what is the use, and each one I will discuss in detail. So those who want to know about the ICMP protocol, I request you to watch the complete video for better understanding. Okay, now as I said earlier also, the ICMP protocol will be there in the network layer. Okay, in network layer, we have the main protocol called IP. On top of the IP, we have ICMP and ICMP protocols. And the below of the IP, you have ARP protocol and RARP protocol. I hope you have already know about ARP protocol and RARP protocol. If you don't know, I request you to watch my previous videos. There I have discussed about the use of ARP protocol and RARP protocol in a proper way. And now let me discuss about the ICMP protocol here. Now ICMP will generate its data and will be sent it to the IP. IP header will be added to that one and send that information to the down layer, which is a data link layer. So for ICMP, the IP header will be added. Are you able to understand? And then it will be sent to the data link layer. Now you can ask me, what are the uses of ICMP protocol? ICMP protocol can be used for two purposes. One is that for generating the feedback. There is a problem has happened. Because of some problem, the whatever the packet the source has sent has not delivered to the destination. Then the intermediate node or a router will provide the feedback. Then source will understand, okay, because of this problem, the destination could not able to receive my packet. So it can be used for feedback or for errors. And even it can be used for ICMP request and also for reply. Meaning is that source can request something and the routers or destination can provide the reply for it. Are you able to understand? Similarly, like ARP request and ARP reply, we have ICMP request and ICMP reply. So we will discuss about feedback, what are the feedback problems are there and how it will be solved. In the next video, I will discuss about request and reply, how the ICMP can be used for request and reply. So where we can use for the feedback, ICMP protocol, where we can use for the feedback is that we can use it for 5 cases. The first case is that whenever the TTL value, time to live value is exceeded. If the time to live value is exceeded, the intermediate node or router cannot send the packet to the destination. Then it is router duty to generate a ICMP packet and sends to the source. Then source will understand whatever the time to live value I kept is less than the destination where in which location. Suppose if I kept 4, I should keep more than the 4. That is what the source will understand. Next time when it is sending the packet, it will keep the more TTL value so that it can able to receive to the destination. And another one is parameter problem. Okay, when you have sent a packet in the network layer, obviously you will add the IP header. In IP header, you kept some value. Let's take the don't fragment value. You kept 1. However, there should be a fragmentation should be done. Then what the router will do, because you said that don't fragment this packet, so router cannot fragment the packet and send to the receiver. Then what the router will do, it will generate a ICMP packet saying that because you kept the don't fragment value as 1, I could not able to fragment, so you please modify yourself. So even that feedback also will be provided with the help of ICMP. And even feedback will be provided source quench and also source redirect problem also. Okay, and then destination unreachable. Even if your destination is not reachable, then also the intermediate router will provide a feedback to the source. Are you able to understand? If any of these 5 problems has happened, ICMP protocol is useful for providing the solution. But however, every time the source will not get the ICMP feedback message. Why it's so, I will discuss. Let's take that you have a source, okay, you have a router R, you have another router R, let me make it, this is R1, this is R2, and you have a destination D. Now source has sent a packet, it want to traverse to the destination. What the source will do? It will generate a packet and it will forward to the router R1. Now router R1, what it will do? It will send to the router R2. When the router R2 can receive the packet, if its buffer is empty, some space is there in its buffer to receive the packet and process it and send to that. But let's take that this buffer is full. Are you able to understand? So then what the router R2 will do? It will discard the packet saying that my buffer is full, I cannot do anything. Then what the router has to do? It has to generate a ICMP feedback packet and send to the source, because you have sent this packet, however due to some problem I cannot able to forward to the destination D. That is the feedback the router R2 has to do. Now first it has to send to the router R1. Now the router R1 is busy here, means this buffer is full. Then what it will do? It will drop this ICMP packet, because router R2 has sent the ICMP packet. However, router R1 is not in a position to receive the packet and send to the source. So it will drop this ICMP packet. Now what it will do? Once it dropped the packet, it has to provide a feedback to the router R2. I have dropped your packet. Again it will generate a ICMP packet. So what is happening? These ICMP packets are going in a loop. Finally the source is not receiving that information. Are you able to understand? So to overcome that problem, and if you are doing like this, the traffic in the network will increase. So that's why to solve this problem, what they have said, if you are generating a IP packet and sending it, obviously if source is sending a packet, it will come from the network layer to the data link layer. So your packets will be IP packets. If the some intermediate router or destination could not able to receive that information or could not able to forward to other node, then it will generate a ICMP packet for providing the feedback to the source. But if an ICMP packet is dropped, you will not generate another ICMP packet. Are you able to understand? So that's what I want to say. If ICMP packet was generated by router R2, it is dropped at router R1, source will not receive it. So even with IP and ICMP, still it is not reliable. I want to say that ICMP is not a reliable protocol. Sometimes whatever the feedback you are sending will be dropped before reaching to the source. I hope you have understood. Please note down this very important point. Is it clear? I hope you have noted down in your notebook. Now let me discuss these problems and how the solution will be there. TTL exceeded. TTL exceeded meaning is that you have a source, you have a router R1, you have a router R2 and a destination. While sending the packet, source will keep the time to live packet value as, suppose let's take it has kept 1. Okay, it has kept the 1, but how many hops it has to go? 1, 2, 3 hops it has to go to reach to the destination this packet. However, source does not know how many hops are there between the source to the destination. Then what it will do? It has kept some value and it has sent this packet to the R1. This TTL value in where it will be there? In the IP header. Am I right or wrong? So you are sending an IP packet with a data. Now TTL value when it comes to the router, it should be decremented by 1. So value will be updated to 0. When R1 receives this information, meaning is that this packet should not be forwarded to others. So then it will could not able to send this packet to the destination. It will drop this packet from the network. That is what the meaning. Am I right? If the TTL value becomes 0, it should be dropped from the network. Then what is the information there in the packet? Source address is there, destination address is there, all other information is there, and data is there. Then it will say that I could not able to send your information to the destination because TTL value becomes 0 or TTL value is expired. So it knows the source IP address and then it generates the ICMP packet and send to the source. Then source will come to know the feedback that the TTL value is exceeded. It becomes 0 before it reaches to the destination. Next time when it is sending packet, it will increment the value of TTL and it will send. Okay, so I hope you have understood how the ICMP feedback packets will be useful for TTL for the source. Now we will discuss the parameter problem. The parameter problem, why it will happen is that you have a source, you have a router, and you have a destination. Let's take that source and destination are there in different networks. Each network has a MTU. Let's take that source is generating a packets of 400 MB size. And when it has generated, we said that in IP header, we have 3 flags. One is 0, one flag is almost kept as 0 every time. And you have DF and we have MF. What is DF? If you kept DF value is 1, meaning is that you should not fragment this packet. You are telling to the intermediate routers, don't fragment these packets. If you can able to send the packet, send to the destination. Otherwise, you don't send, you drop the packet. Am I right or wrong? Are you able to understand? Is it clear? Suppose let's take that the DF value, the sender has kept 1, meaning is that this entire packet 400 MB sent to the, not 400 MB, okay? Let's take that 400 bytes. Okay, 400 bytes of information, you send it as a single packet. Okay, now the router has received this packet, but router outgoing link, that MTU is 200 MB only. Then obviously it has to do fragmentation, but it cannot do the fragmentation because the sender has kept the DF value as 1. Then router will drop this packet and generate a ICMP packet and send to the source that my outgoing link packet is 200 MB. So, but however you kept the DF value is 1, so that's why I could not able to send your packet to the destination. Am I right? That feedback will be provided to the source. So next time source either generated 200 MB, not 200 MB, 200 bytes of packet, or it will keep the DF value as 0. If it keeps DF value as 0, router can fragment the packet next time. So this will be useful for the source to send the packet to the destination successfully. Are you able to understand? Now let me discuss what is the source quench problem. You have a source, you have a receiver, and you have a destination. Source is keep on sending the packets to the router that you send my packets to the destination. Now the router is too busy, its buffer is full. It cannot able to handle the requests of the source. So then what the router will send a feedback that you are sending me more packets beyond the capability of mine. So you please stop sending the packets. So that network traffic will reduce and also packet drops will be reduced. Because if router could not able to handle these packets or its own buffer is full, obviously it will drop the packets. If the packets are dropped, the packet delivery ratio will be reduced. So it will provide a feedback to the source that you are keep on sending me packets beyond my capability. So please stop sending me packets or stop sending packets for some amount of time. Okay. So that is the source quench problem and how the ICMP packet will be useful for providing the feedback. Now let me discuss about the source redirect problem. You have a source, you have router R1, you have a router R2, you have router R3, router R4, router R5, and you have a destination. Meaning is that you have multiple paths are there from source to destination. Whatever the data the source is sending, it can send from router R1, R2 to the destination, or from source R3, R4, R5 to the destination is there. Now let's take the source is using a strict source routing protocol. Meaning is that source is keeping the information to the destination complete path R3, R4, R5. Then what the router has to do? They have to use this path and send to the destination. Router no need to find the alternative path. Let's take that source has sent this information like this. When it received to the some router R4, it understood that this path is lengthy. It knows that to the destination, if you use this path, you can reach to the destination more quickly or less number of hops as compared to this one. This information router R4 can send to the source. The next time source will use this path instead of this path. Are you able to understand? So source redirect. If the router knows this information that destination, if it pass, the source has passed this information using this path, it will be less number of hops. If it has the information, it will provide a feedback to the source. Obviously it will send the packet, but it will even send the feedback that this is, if you do use this path, it will be better for you. Are you able to understand? So this is what the source redirect. Now we will discuss about the destination unreachable. We have a source, we have a router, and we have a destination. Every time, sir, you are taking source, router, destination, because in computer networks, that to wired communication, always we should have a router to send a packet to the destination. Obviously, you can even have the switch, but just nowadays we are using the routers. Because this is in another network, this is in another network. So obviously I need to have a router. Okay. Now the source has sent this information to the router. Now router was sending the packets to the destination, but however, destination is not reachable. Meaning is that destination is either switched on or there is some issue. Destination is currently not available. That information also need to provide the feedback to the source that whatever the packets you are sending to the destination is currently not available in the network. So that information will be provided to the source. Is it clear? Are you able to understand? So the destination unreachable, even we have another one is destination port not available. What is meant by destination port not available? I will discuss. So destination can be not reachable, destination host or destination port also not available. Now let's take that at the source, you will have the packet comes from the application layer, transport layer, network layer, data link layer, physical layer. Then only that information will be sent to the router and it will be sent to the destination. Now at the transport layer, what addresses we will use? When message comes from the application layer, for that message, the source port number and destination port number will be added. Now let's take that it uses a destination port number called 80 and it has sent to the network layer. Network layer has added the IP header to this data and sending to the source. Now it has delivered to the destination, physical layer. Destination is available. Okay, physical layer, data link layer, network layer. When it comes to the transport layer, what it has to do? It has to demultiplexing the packet. Means whatever the packet comes, it has to send to the particular host. That's why we will call it as transport layer will do the end-to-end communication or port-to-port communication. Let's take the destination port number 80, which is not currently available. Is it clear? Or it is too busy with the previous packets. Then the destination will send a feedback to the source via router R1 that my destination port or particular port is currently busy. That's why I could not able to receive your packets. So these are the information the intermediate nodes or the destination will provide the feedback to the source using the ICMP protocol. I hope you have understood all these problems and the solution for them also. If you still have any doubts related to the concepts what I have discussed in this video, you can ask the doubts in the comment section. I will provide the solution for your doubts in less than 24 hours. In the next video, we will discuss about how ICMP can be used for request and reply packets also. If you really like this video, please press the like button, share the videos with your friends, subscribe to my channel. Thank you for watching my video. Have a nice day.